Hi, my name is Isabel Andrade, and this is my Lab 1 charge tapes for Physics 2212. In this experiment, two pieces of charged tape are prepared and their interactions with each other and other objects are observed. From these observations, we can determine the total charge on the tape and the point charges on GloveScript. A summary of the findings is shown, where we see that the charge of the tape is positive and had an electron deficiency of 6.72 times 10 to the 10 electrons. Some of the fundamental concepts used in this lab include Newton's second law. Newton's second states that the net force on an object is equal to the change in momentum of the object over time. From this law, we are also able to derive the updated velocity formula. The second key concept used is the electric force through Coulomb's law. This is used to express the force through which charged particles attract or repel one another, such as like charges repel and unlike charges attract. Below, we can also see the equation used, which states the electric force is equal to the Coulomb's constant times the product of the charges of the particles divided by the squared distance between the particles in the direction of r hat. For this lab, some key assumptions were established. Firstly, the tape acts as a point charge that is located at the center of the tape. Second, we assume that both the tapes have the same amount of charge. And lastly, we can ignore air resistance. Here I've laid out the procedures of the experiment and the type of testing done to analyze the interactions. Firstly, we create the U-tapes on a flat surface, with a base of tape on the surface and another tape on top. Then the top tape is pulled up and hung vertically from the surface. Then we observe the interactions between the two U-tapes, and then observe the interaction between the U-tape and a plastic object, which I did a plastic pen. Here we have the main observations from the interactions with the U-tape. After the interaction between two U-tapes, it was observed that they repel. However, when the U-tape interacted with my hand or with a pen, it attracted. In this experiment, the plastic pen was rubbed on clothing, which caused the pen to be negatively charged. And lastly, the interaction between the suspended U-tape and another U-tape repelled. From these observations, we can conclude that the U-tape is positively charged, since it attracts to an object that is negatively charged, but repels when the object is positively charged. According to Coulomb's law, like charges repel and opposite charges attract. Thus, we can conclude that the U-tape is positively charged. Here is a free body diagram of the interaction between the held U-tape and the suspended U-tape, in which both tapes are repelling each other. This system includes tape A and tape B, and the surroundings is the Earth. For the suspended tape to float, it must be in equilibrium, thus the net force is 0. Now here we have the experimental data and calculations with the charged tapes. From these calculations, it is important to note the number of atoms in the tape and the weight. All relevant equations are noted. The tape length and width was measured through measuring. The number of atoms was calculated by dividing the surface area by the area of an atom, which is 1 times 10 to the negative 10. Next, we continue with the calculations. The force of gravity is the mass of the tape multiplied by gravity, which is negative 9.81. Then, to calculate the charge of the U-tape, the forces of the tape must be balanced. Thus, by manipulating the equation of the electric force, we are able to solve for Q, the charge of the tape. Then, since we know that the charge of the tape is positive, there must be a deficient of electrons, which was calculated by dividing the charge of the tape by the charge of an electron. The computational model was done in GloveScript. Here I have my code showing the relevant calculations. For the section of the constants, the values are taken from the previously shown calculations. The Opes constant is the Coulomb's constant. All equations are taken in the same method as previously denoted but written in the GloveScript language. This slide shows a visualization of the code, with the results of the deficient electrons, number of atoms, and the ratio of deficient electrons. Here is an overview of the results. Because the tape is positively charged, there will be an electron deficiency. There is a static equilibrium for the suspended U-tape to flow. Thus, the net force is 0. Additionally, it is important to note that there are possible rooms for error, such as incorrect calculations when it comes to measuring the tape, such as its length, width, and the separation distance. Additionally, obviously, errors in rounding when we were doing the calculations could have resulted in errors as well. If the charges were swapped between electrons and protons, the electric fields of electrons and protons would change, as the electric field for a positive charge is outwards and from the source, and the electric field of a negative charge goes towards the source. However, the observation itself would not change because, once again, like charges would continue to repel and opposite charges would continue to attract. Swapping the charges did not change the interaction between the charged objects touching. Additionally, it is important to handle the tape as little as possible because touching the charged tapes with the hand would lead to a transfer of electrons, specifically the transfer of electrons from the surface of the hand to the positively charged tape. Thus, would decrease the positive charge on the tape, leading to weaker interactions.